get going there shortly. Sometimes there's some delays with internet connections. Come on. There it is. All right. Okay. All right. Yeah. So -4, -8, -12, -16. Okay. What? Sometimes it's easier just to figure out what the next term is first.
Would it be 20?
It would be -20. Do you see how it alternates from positive to negative?
Yeah.
So maybe we type that in there. Let's see what's in the drop down also with the pattern. Okay, so in short, it's arithmetic if it goes up or down by the same amount. This one is not arithmetic because while it has the appearance of going up or down, you can see it goes positive to negative. It actually alternates. So we can go neither. Geometric is something different. We'll see.
Okay.
Yeah. Okay. So this one's the toughest, the nth term. Okay, and the shortcut here to do this is boy, I wonder how they want you to do this. Let me go ahead and grab a snip here, and I guess I'll have to share my screen. It's possible what I'm about to give you will not be accepted because it's expecting something slightly different, but we'll get to that when that occurs.
Okay.
Okay. So the nth term, if it was arithmetic or geometric, there is a formula for it. And that's why I'm not even like, so is there something where you can say a, well, that's not even right. So it's like this. It's like -4, -8, -12, -16, -20. So it's going, boy, let's see if we can get this. This is +12, -14. But this is now +28. So like the thing is here is you're taking the previous number, an -1, like this, whatever this previous number is, and then you're changing its sign, and then you're adding to it 4, or you're adding to it -4. Do you see that? Like
Yeah.
if this went to 4, you're adding 4, but when it's so maybe that is as simple as we can make it. It's -1. Take the previous number, okay, change its sign. So I'm not sure what it's going to want you to accept here. So let me have you go ahead and share your screen again one more time here.
Okay.
Did you have any other problems like this? Like is number 8 like this? Or is
Yeah, I
want
to say that these are the rest. That's the rest of them.
But is number 8 different? Oh, okay.
Yeah.
I was trying to get to one where you have an answer for it already to see if it's no. Okay, let's go to this next one. Okay, so let's just if you're okay with it, I just submit this as is, and let's go to the next one because this we're spending a lot of time on tonight. I don't think is going to occur. It's not going to matter ultimately. All right, so let's look at this one. Is it going up by the same amount?
Is it going up by 5? Yeah, it is.
It is. So this is geometric. If it goes up or down by the same amount, it is geometric. The next term you can figure out pretty quickly. It is not 5.
Mhm.
No.
Oh, it's not 5?
The next term, that means what comes after 16.
Oh, 21?
Yes. Okay, you're the next. Okay, the next. So I guess the pattern is arithmetic. If they're going up by the same amount, I don't know. Maybe I said geometric, but it's arithmetic. So let's redo that.
Oh, okay.
The next term is the number that comes after 16. It is 21.
Oh, okay.
Okay.
Got it. And
Okay.
this
Now
is
the
5.
formula. No, it's not 5. It's a formula. It's a formula. So the
Okay.
formula is, and I'm gonna snip this in because you do need this, some explanation on this. So let me grab that and share my screen. Okay, so there's a formula for this. It's the AN equals A1 plus N minus 1 times D. Okay. But there's a shortcut to this. So the shortcut is you figure out what is the previous number. What goes before the 1? If you're adding, notice like what would you add 5 to get 1 to become 1?
-6.
-4. -4 plus 5 gives you 1. So the shortcut is the formula for AN. It's that -4 plus the number that you kept trying to put in as the answer 5, because that's the difference, times N. So this is your answer, and hopefully we get to do another one like this, because you take this previous number, then the common difference between them, and then always this letter N. It is this formula on the right, but this is the shortcut. So in terms of what you need to enter, it's this box here.
Okay. All right.
Okay, so the pattern is, now, is it going up by the same amount? Like when you go from 1 to 2, 2 to 4, 4 to 8, meaning like, does it increment by the same amount? Like, are you always adding the same number?
Yeah.
Okay, so if you're adding the same number, what are you adding to go from 1 to 2?
2.
You're adding
Or
1.
1.
So to go from 2 to 4, if you add 1, is that the same?
No.
No. So this one's different. Okay, so I'm sharing my screen again here. What you're first hoping for is what I said. It's like, how do you go from 1, 2, 4, and 8? And what you hope is you can add the same thing, but this time you can't. You actually are multiplying by 2, multiplying by 2, and multiplying by 2. Do you agree with that?
Yeah.
Okay, so when you multiply by 2, or when you multiply in general, that is called geometric. So arithmetic is when you're adding or subtracting. Geometric is when you're multiplying or dividing. So that's going to be the answer here. Can you tell me the next term? 1, 2, 4. But it's not going up by 2. It's multiplying by 2.
Oh, 16.
16. Good. So your next term is 16. So you should always be able to get these two, because you should be able to look and say, okay, it's geometric if I'm multiplying or dividing. It's arithmetic if I'm adding or subtracting. The AN, okay, the AN, well, there's a formula for this, for geometric, and it is the first term times what's called the common ratio between terms to the n minus 1 power. Okay. And you're going to have to know this formula, or at least be able to recognize it when we do some more problems, but I'll obviously give it to you here. So the first term is this 1. So 1 is A1. R is the ratio between terms. And the ratio between terms is like 2 divided by 1, or 4 divided by 2, or 8 divided by 4. And what do these all equal? It's the same as what's up here. Jayla, do you need a few minutes to take care of something before we keep going?
No, I was just writing something down.
Okay. So yeah, I'm trying to get you to tell me what the common ratio is, because that's the key thing here. It's the same as this right here. It's 2.
2, yeah.
Okay, because each of these equal 2. And then it's to the power of n minus 1. So somehow you have to get this part in the box into your thing there. And I'm happy to look at your screen and see if I can help talk you through it.
Okay. So, what would I put in for this exactly? Because I'm just confused on that part.
I'm not seeing anything on your screen yet. Right yet.
Oh,
Okay.
it must be loading.
There it is. So it's the number 2, and then to the power or exponent, and then n minus 1 in your exponent.
Oh, okay. So you don't put anything in for n, it's just n minus 1.
N is your variable. It's like X. So you're
Right.
gonna treat it like that's the 1.
Okay. Oh, all right, cool. Okay. This pattern. Wait, it's decimals.
Okay, so again here, what you're looking for is like, is it going up by the same amount? So you've got a calculator on the right there. If you can go to the right for me, type in 3.8 minus 3.7. I'm sorry, 3.8 minus 3.1. And those are the 3.1, not 3.7. And those are the first 2 numbers. Do you see that?
Yeah.
Do you see where I got those 2 numbers? Okay, so that 0.7, keep that in your mind. Remember that number. Now delete those 2 numbers and type in 4.5 minus 3.8. Okay. Is it the same?
And then, yeah. And it would be 4.5
and then try,
minus 5.2.
well, it's the larger minus the smaller, so it'll be 5.2 minus 4.5.
So would it be
Well, so first thing is, like, do you see that it's the same every time? It's going up by the same amount every time.
yeah,
Okay, and what is the amount that it's going up by every time?
0.7.
0.7. So that's arithmetic. When it goes up by the same amount every time, you know, that is arithmetic. So now the next term, to get the next term, you take that 5.2 and what do you add to it?
0.7.
7.
5.2. Okay. And then what is the like equation for arithmetic?
Okay, so this is, yeah, so go put your cursor, go back to, go ahead and put your cursor in that box, or it doesn't really matter. What would be the number before the 3.1?
Um,
And if you're not sure, you can subtract 0.7 from 3.1 to get it.
2.6 or
Use the calculator. Let's
2.1, yeah.
minus 0.7. Okay, so
2.4.
so go ahead and type in 2.4 into the formula. And then plus. So the next thing you need is that common difference, that 0.7 that you've been using. So put in 0.7 there times n.
I'm sorry, it was 2.4 plus what?
The common difference, which is 0.7 times n. And that's it. So it's the previous number plus the common difference times n.
Okay.
Okay, so this time type in 16.8 minus 9. Okay, so hold that number 7.8 in your mind. And you can actually hit enter on that right screen there. That's probably would help.
Okay.
And then do 24.6 minus 16.8.
Okay.
Are they the same?
Yes.
Okay, so the next term comes from like what you just did there, 40.2. Now the nth term, you have to find the term before the 9. So you want to go back over your calculator there on the right and do 9 minus 7.8. Okay. 1.2 plus, and then it's the common difference 7.8.
Times n.
Yes.
All right. These are actually pretty easy so far.
Well, yeah, until there's proof that it's different.
Oh yeah.
So let's see if this one is the same. Do that subtraction. It's got to be the one on the right minus the one on the left. So it's got to be 4.2 minus 5.8.
Negative 1.6.
Okay, that's okay. It can go down. So then it'll be 2 minus, or 2. I'm sorry, it's 2.6 minus 4.2. It's formatted really poorly.
Negative 1.6. And then 1 minus.
Yep, 1 minus 2.6.
Minus 2.6. Yep.
So I'm convinced like those are all the same. I mean, you can keep going if you want. And since they are the same, it's arithmetic. So the next term is minus 0.6 minus 1.6.
Negative 2.2.
Okay. Yeah. Good. So the nth term is you have to find the term that you would the one before 5.8. So because the numbers are going down, you're going to actually add 1.6 this time because it has to be bigger.
So I do 1.6 plus 2.2.
No, you go to the first term, 5.8, and write 5.8, and instead of subtracting 1.6, because when you subtract it, you're going to get 4.2. You have to add it to get the one before it.
Okay.
So it's 7.4. There it is. Yep. This time though, it's minus instead of plus, minus 1.6. times n. There it is.
Okay. Oh, and that was it.
The next one must be geometric.
If it'll load. Okay.
All right, so the way you're going to answer these is the bottom number is usually always 1. The top number is the number of terms. So how many terms do you see there?
5.
5. So that's that top number. Okay, now what goes in that middle box depends on what kind of a series or sequence this is. Is this going up by the same amount?
Yes.
Yes. So this is where we have to write the formula right in that box. So what's the number that would go to the left of 7?
3. Oh, to the left. 4.
4. So write 4 plus, what is it going up by each time?
3.
Okay. And instead of n, it's I, because I is the variable, which is a small modification. So you're going to put I there.
Okay.
Okay. So give that a try.
Cool. Right.
Great. That top number is the number of terms. Yep. And then is it going up by the same amount each time? It is. You have to figure out the term to the left of 5, which isn't there.
-1.
The 6 can't be there. If you go back, if you were to look at the previous one, it's the number to the left of 5, which is -1, plus the difference, what's going up by, times I. Perfect.
Is that right?
So what that formula gives you is like how to find each of those numbers.
Okay.
Now this one is going up forever. Do you see that? It says plus ...
Yeah, it's for infinity.
Yeah, I think. I mean, I don't actually like it does. Yeah, we don't think that yeah, it probably is infinity, but it hopefully doesn't mean the 5th one there. So grab that infinity symbol.
Okay.
And then what goes in that middle box is, again, if it's an arithmetic sequence. Now, is it going up by the same amount each time?
No.
No, it is. It's not. So that means it's a slightly more complicated problem. So let me go ahead and grab this from you. All right, so let me share my screen. All right, so what I notice is it's going up by 3, and then 5, and then 7. Do you see that?
Yeah.
It goes up by 3 and 5 and then 7. So if we I don't want to do this. So the next number would be up by 9, and that would be 28.
Mhm.
So how do we get, so the
It's going by
idea,
2.
yeah, it is going by 2 each time. But the question is, like, how do we make I equals 1 produce a 4, I equals 2 produce a 7, and so on. Okay, so it's like this game that you're playing each time to figure this out. The thing is, though, these are nicely going up. So like, it's the when it's 2, we really want to, I don't want to say this, my words are bad here. It's 2n plus 1, or I'm sorry, let me do it this way. 2i plus 1, right this way. 2i plus 1. So 2i plus 1, do you see how if you put a 2 in there, you get 5?
Yeah.
Okay. And if we go, we can also do this other way, 2i minus 1, that gives you a 3.
Yeah.
So we're starting out with the, see, I'm still struggling here because it's like, well, is that what they mean by this? So if we take out a 4, everything, 0 plus 3 plus 8. Okay, that's not gonna work. The problem is there's a lot of ways to write this, and I don't know which one they want. So your I, it's the first one is 1 is I plus 2i minus plus 1, 2i plus 1. It's 4. So when I equals 1, 2i plus 1 equals 3. So we could do 1 plus that. When I equals 2, we want 2i plus 1. So that gives you a 5.
Damn.
It goes up by 5. So this, like the answer is, wonder if we can do it recursively. It's, wonder, I probably don't want that. Let me check an online tool here and see if I can come up with a formula here that's not as complicated as the one I'm thinking of.
Okay.
The first one said it doesn't support this type. Let's try it. Let's try this one. It's not supported. Okay. 2i plus 1, but we've got to add it to something. Let's see. Yeah, this is kind of like that last problem. Why don't you go ahead and share your screen again? Let's just move past this. Hopefully the next couple are more clear. I don't even have a good way to explain this to you at the moment.
Okay, no, that's fine.
I mean, it'll accept two parts of it, but you're welcome to. All right.
I'm missing infinity for
This is the same problem. It's going up by 3, up by 7.
Should we move on to the next one?
Yeah, go to the next one here. Okay. This one is easier to do. So let's go to that calculator on the right. It might be good to clear out everything you've got there. There's a clear all button there. Okay. So I don't know if it'll do this. Type in n equals 1. And hit enter. Okay, now type n squared minus 1. Okay, hit enter. Okay, it did work. All right, so when n is 1, what is n squared minus 1? Can you see that value on the right?
Mhm.
Can you type that 0? So type 0 in that third line. Plus, put a plus there next to the 0. Now go back to that first line where it says n equals 1 and put in n equals 2. Okay, now what is the next output? Do you see how it's 3? So put a 3
Yeah.
there, plus. And then do it again for n equals 3. Okay, and then put the 8 down there. Do you have the, so that's where you stop. You stop when n is
Yeah.
5 and go,
And will that just be my answer, 50?
go ahead and type that in on the left. So what you did is you put the values in, or you found the sum. You like putting each value of n into that thing.
Right. Okay. That's simple.
Okay, so this one will do similarly. This time let I equal 1 instead of n in line 1. Hit enter,
And
and then
take
2i,
the 0.
and then hit enter. And so that's your first value. The 2 on the right is your first value. Plus, and then change I to 2 because that's the next increment. Yeah, 2, there you go. So 2i is 4.
Okay.
All right, so I might have an answer for these previous problems. Let me just check this. N squared plus 3.
No.
Okay, yeah, I do. We can go back to the results at some point. All right, so this one kind of same deal. Good.
Okay.
So 35.
Do I just put
Yeah, 35
5 plus or 35?
plus, and then do the next one. After you get this one, let's go back and do the previous problems.
Okay.
There's a problem. The numbers need to go up by.
Yeah.
So when I is 1, you start out with I is 5. Yep, I remove that 35 down there at that first one. Yeah, that'll do. And then it's 28 is the next one. That's good. Plus, and there's your 35 again.
Okay. I was getting me a little confused there. So 105.
I don't think you submitted. There you go. Great.
There we go. Just to make
Go to
sure.
the previous one, please. One of the ones that was the 4 plus 7 plus 12 plus 19. So I looked into this while you were typing in some of those. Go to the next one. And do you, okay, right there. So what's interesting is that this one is actually I squared plus 3.
Oh. So when it's like, how do I say it?
The reason is because this what's called the second difference is the same, which means it's a quadratic. I don't know how you would know this. It's the truth. So you know, so go to the next one, please.
Okay.
This one follows a really similar pattern. It's not I squared plus 3 though. It's a variant on this. Because
I squared plus
it's
5.
well, you're starting at -1, so it's actually -2.
What?
Yeah. Because when you add 1 to it, you get there. So anyway, like if we need to, I will cover that in more detail, but
Yeah, because I'm definitely not gonna get these.
yeah. So let's go back to the grouping that we were working on. Okay. Yeah, so this time you got to let n equal 0. Not 1, 0, is because
Oh.
it's the lower index, that thing below the Greek sigma. And then type in n cubed or n to the power 3. And then 0 is your first value. Yep. 0 plus. And then do the next one. Good.
Okay.
So you're going to want to change n equals 1 to k equals 1. And believe it or not, you're doing programming right now.
Really?
Yes. Yes.
This is not fun. It's fun, but it's not fun. It's like
Well,
so many like going back and forth.
Well, the programming would a professional programmer, someone with a little more experience, would do it slightly differently, but this is truly programming. So
fun.
well, this is way better than doing it by hand.
Right.
As you can see, it would be a lot of effort.
Cool. And last one.
Three. You're starting at the lower one. Not 1. You're starting at 3 this time because it shows you k equals 3.
Oh,
and then
okay.
5k minus 2.
Minus 2.
Yep.
And 13.
13 is your first number.
Now I go to 4.
Yep. You always got by 1.
Okay. And then once I get to 6, I'm guessing I stop.
Exactly.
Okay. All right, and that is all that I have for today.
Great. Well, I appreciate you scheduling. I'm glad I got to help, and you know, did excellent. So see you next time.
All right, see you next time. Thank
Enjoy
you
the rest
so
of your day.
much.
Bye now.